Hey there. Today I'm going to talk about the effect of weak hydrofluoric acid on titanium for roughening titanium surface. Surface modification is carried out to increase the osteoinductive property of the metal, to increase the cell activity around the implant, to increase the bone apposition around the implant. In other words, bone implant contact increases, hence firming the adhesion of the implant to the surrounding bone. The surface modification is carried out either by microtopography or nanotopography. Microtopography is carried out where sandblasted and acid etch technique is done. That is, either sandblasting grids are medium or large, and acid etch is carried out in the later part. The nanotopography is carried out where discrete crystal deposition is done on the implant surface. Either or laser ablation of the implant surface is done, anodic oxidation is carried out on the implant surface, or titanium oxide is blasted. Titanium oxide particles are blasted on the surface of the implant and it is etched later on. The various agents used for etching the titanium surface are either concentrated sulfuric acid, concentrated hydrofluoric acid, concentrated hydrochloric acid, concentrated nitric acid. Currently, the most used one is the multi-etch solution that contains ammonium persulfate and sodium fluoride. In the past, a lot of studies have been carried out where a various combination of these acids have been done, although none of them have been combined with multi-etch solution, as multi-etch solution itself is a strong etching agent. In the following study, we use grade 4 and grade 5 titanium. Grade 4 titanium is titanium with titanium oxide on its surface. Grade 5 titanium contains titanium, aluminum, and vanadium. So in the following study, we polish the surface of the titanium using 600 grit of aluminum oxide paper or sandpaper. We abrade the surface using 50 micron aluminum oxide powder. After this, the surface of the titanium is etched at various time points, that is 5 minutes, 7.5 minutes, 10 minutes, 12 minutes, 15, 17.5, and 20 minutes. After the etching process is done, the titanium discs are cleaned in the ultrasonic bath for 15 minutes, and then they're decontaminated using 70% ethanol. After this, the analysis of the surface is carried out, where the surface roughness is analyzed. The surface analysis is done using scanning electron microscopy, light microscopy, heat analysis, scanning electron microscopy with heat analysis, atomic force microscopy. As we can see, at 5 minutes, the SEM shows a grayscale image. And as we progress to 10 minutes, the darker grains on the surface decrease. In the light microscopy with heat analysis study is where basically a heat beam is shot on the titanium surface. The peaks get heated first and the base get heated later on. So in the similar fashion, as we can see, the etching from 5 minutes to 10 minutes, as the peaks have reduced, the number of peaks have also increased around the center. In a three-dimensional image, the red spots are mainly the peaks and the blue region is the base area that has not been heated as yet when the analysis was carried out. Similarly, a two-dimensional image with the help of SEM imaging and heat analysis has been done. As we can see, the red spots have gradually spreaded. Next is the AFM. AFM is used for a precise for a precise measurement of the surface roughness. The AFM is capable to record a surface area of 15 by 15 microns. AFM in the following image, as we can see, as we progress from 5 minutes to 10 minutes, the number of peaks and number of valley gradually decreases. Similarly, with 12.5 minutes, 15 minutes, and 17.5 minutes, we can see the number of peaks gradually increases, suggesting the reduction in the total height of the surface. And as we can see in SEM with heat analysis, the red spot, the red demarcation on the surface is gradually spreading, suggesting of slightly reduction in the peak height. The AFM also suggests a slight reduction in the peaks and the valley, although in these images, as it records only 15 by 15 micron area, it only provides a data suggesting the gradual decrease in the peak height and slightly shallowing of the valleys. After etching for 20 minutes, we come to a conclusion where grade 4 titanium is etched for 15 minutes and grade 5 titanium is etched for 20 minutes. This etching gives a result that is similar to the commercially used implant, that is 0.8 to 1.3 micrometers of surface roughness. The surface roughness can also be measured using a surface profilometer. Uh, in this, a small probe that runs on the surface of the titanium gradually records the valleys and the peaks, hence uh, imprinting that on a paper and providing the peaks and valley as the final result. In our conclusion, we would say that 0.5% of hydrofluoric acid is an effective etchant used for surface modification of titanium and titanium alloys. This is a summary.